Not long ago, wastewater was treated as waste, something to remove, treat, and discharge. But today, that thinking is changing. In this episode, we explore how wastewater is being reimagined as a source of water, energy, and nutrients, and what that means for Melbourne's future. As climate change intensifies and Melbourne's population continues to grow, traditional water sources like rainfall-fed reservoirs and rivers are becoming less reliable. Even with desalination and conservation, we need to think beyond old models. One idea gaining global traction is purified recycled water. It's already happening in places like Singapore, Orange County in California, and Windhoek, Namibia. These cities are turning wastewater into safe, high-quality drinking water using a process known as advanced water purification. So, could Melbourne be next? Let's explain how it works. Advanced purification begins with secondary treated wastewater, water that has already been cleaned of solids and contaminants. It then passes through a series of treatment barriers, including microfiltration to remove bacteria and suspended solids, reverse osmosis to eliminate dissolved salts, viruses, pharmaceuticals, and other micropollutants, and ultraviolet disinfection, often combined with advanced oxidation, to destroy trace organics and ensure human safety. The result is ultra-pure water, often cleaner than conventional drinking water. In some cases, it's so devoid of minerals, we actually have to add things back into it to ensure it doesn't pull those key minerals from our own bodies as we consume it. Yep, that pure. Importantly, these aren't theoretical technologies. They're tested, regulated, and already in use. In Singapore, the new water system supplies up to 40% of the nation's demand. In California, Orange County's groundwater replenishment system has been operating for over 15 years and produces millions of litres a day. Windhoek has been using direct potable reuse since the 1960s, setting a global precedent. So what's holding Melbourne back? The answer isn't technical limitations, it's perception. The phrase toilet to tap has been a stubborn barrier to community acceptance, but it's a misleading term. In reality, all water is simply reused, and it always has been, whether through nature's hydrological cycle or our own engineered systems. It's the same stuff that dinosaurs drank and peed. That's right, we're drinking millennia-old dino pee. When it rains on a farm, it soaks into the ground, flows into a stream, and eventually reaches your tap. It's passed through countless environments and biological processes. In numerous locations throughout Australia, inland towns draw water for their own supplies downstream of other towns, whose treated wastewater has often been returned to the same stream. So indirect reuse is already around, whether we want to acknowledge it or not. Advanced purification simply accelerates and controls that natural process, removing more contaminants with greater precision. Here in Melbourne, we're already recycling water for non-drinking water uses. Class A recycled water from the eastern and western treatment plants is used to irrigate parks, golf courses, and farmland. In many new housing estates, it's piped directly into homes for flushing toilets and watering gardens. The next step is considering whether purified recycled water should supplement our drinking water supply, especially in drier, less predictable climates. There are two main models: indirect potable reuse, IPR. Purified water is added to reservoirs or aquifers where it blends with existing supplies before undergoing conventional water treatment. Direct potable reuse, DPR. Purified water is introduced directly into the drinking system under strict monitoring and real-time controls. Both approaches are being explored throughout Australia. Perth already has an IPR scheme, where purified recycled water is injected into deep aquifers to replenish the city's groundwater supply. For Melbourne, the main challenge isn't technology, it's building public trust. Community engagement, education, and transparency will be critical. Global case studies show that acceptance grows with familiarity. When people understand the science, the safeguards, and the benefits, support follows. That means engineers and scientists must play an active role in public communication, not just behind the scenes, but out front. But water isn't the only resource hidden in wastewater. Modern treatment plants are also becoming hubs for energy recovery. As sewage breaks down, it releases biogas, mostly methane, which can be captured and used to generate electricity. At the Western Treatment Plant in Werribee, Melbourne Water produces up to 95% of the site's electricity from biogas, dramatically reducing both emissions and overall operating costs. Some of this energy now powers electrical vehicle chargers and site lighting. In the future, we could go further. Emerging technologies are being developed to convert wastewater into hydrogen gas, a clean energy source with a broad potential. Hydrogen production requires plenty of water, and conventionally, sewerage is effectively made up of 99% water. Others are investigating microbial fuel cells, which generate electricity directly from organic matter in sewage. Wastewater also contains valuable nutrients, especially phosphorus and nitrogen. Traditionally considered pollutants, these are now being recovered elsewhere in the world and used as fertilizers, reducing reliance on mined phosphorus and closing the nutrient loop. This shift, often referred to as resource recovery, marks a turning point in wastewater management. Instead of asking, how do we get rid of this? We now ask, what can we recover from this? Of course, these changes won't happen overnight. They require investment, policy reform, and long-term planning, but they're already in motion. Melbourne Water and its partners are currently leading several major research programs, testing advanced purification technologies, mapping public attitudes, and developing business cases for future large-scale adoption. Engineers, environmental scientists, economists, and social researchers are also all involved, because this isn't just a technical issue, it's a community one. If Melbourne chooses to pursue purified recycled water in the future, it won't just be because the infrastructure is ready. It'll be because the public understands, supports, and trusts the system. And that trust won't be built in a lab. It'll be built in conversations, in schools, in workplaces, and throughout households. Wastewater is no longer just a liability, it's an opportunity for cleaner water, for greener energy, for more sustainable cities. The challenge for Melbourne, though, is to harness that opportunity with vision, care, and engineering precision. In our final episode in this Sewerage series, we'll step back and reflect on the entire journey, from Melbourne's public health crisis in the 1800s to the globally respected water and sewage system we operate today. We'll explore the lessons we've learned and what they mean for engineers, planners, and the communities of tomorrow. I'm Paul Michael Angus. Appreciate you joining me.